Exercise 3C, question number 3. We had to find three first term, second, and third. We had to find x, and we had to find the fourth term. Uh, the first term is 3, and the common ratio is x over 3, or you can write 9 over x, both correct. And if you know that you need to write the fourth term you can write as usual with the first term multiply by the common ratio. I will take this one, x over 3 to the power, if it is 4, 1 less than that, 4 minus 1, that is 3. So this is the fourth term basically we need. If we know x, we can work out the fourth term. To find x now, we know that there's one unknown, we need one equation. Uh, so we have to show same thing in two different ways. So common ratio we can show as x over 3, and the common ratio 9 over x, and since it is a geometric sequence they are equal. So x over 3 and 9 over x, when we cross multiply, x square equal 9 times 3, that is 27. Then x square equal 27, we can get the square root. So x equal 3 square root 3, plus or minus. Let me stay with the plus answer, x 3 over 3. And if I simplify this one, how do I get this? Square root 27 means square root 9 times 3, that is square root 9 times square root 3, that is square root 9 is 3, and this is square root 3, 3 square root 3. So the fourth term is 3 times x value, 3 square root 3 over 3 to the power 3. So 3, this is cancel out, square root 3 to the power 3. It means 3 times square root 3 times. So this is become 3, and this is square root 3, and this is 3 times 3, 9 square root 3. X over 3 divided by 9 over x, we can write within brackets. The reason is geometric sequence. Or simply you can take, um, when you calculate x equal 3 square root 3, then you can find the common ratio. Common ratio is x divided by 3, that is 3 square root 3 over 3. 3 to 3 cancel out, so the common ratio is 3. So then you can simply multiply by this one, 9 times square root 3, or 3 times an x. So we know, we already found out that is square root 3. Question number 4. We find the sixth and the nth term. Six terms and nth term. T6 and Tn. Sixth term and nth term. For a 2, 6, 18, 54. We discussed already that if we know first term and the common ratio r, we can write any term. For example, if I want to write term 10, 10 term, 10th term, so we have to multiply uh, from first term, and the common ratio, the power should be 1 less than the term number, that is 10 minus 1. 10 minus 1 is 9. So nth term, so we have to multiply by first term, and the common ratio, the power has to be 1 less than n minus 1. Assume if we have a geometric sequence starting with alpha, and the common ratio is beta. So how do you write the nth term? Nth term is first term multiplied by the common ratio. The power should be 1 less than the term 1, n minus 1. So likewise, uh, we need 6 term. So T6. T6 means first terms multiplied by common ratio. What is the power? 6 minus 1. So AR5 we need. Then nth term. Then AR n minus 1. Now we need to find A, the first term, A equal to, and common ratio R equals 6 divided by 2 equal 3. Now you can substitute 2 times 3 to the power 5, that is 243, 486, and the nth term 2 r is 3 to the power n minus 1. Part B. So in here the 6 terms is AR5, and nth term is ARn minus 1, 1 less than 1. So A equal 100, and R equal 50 divided by 100, that is half. So A value is 100 times half of 5, and this is N is 100 times half of N minus 1, and this is 100 times 1 over 5, 2 over 5. So 100 times 1 over 2 to the power 5, that is 32. 100 over 32, that is 25 over 8. And Tn, so we can leave as it is, or 100 times 1 to the power n minus 1 times 2 to the power n minus 1. 1 to the power n minus 1 is 1. 1 to the power 3, and 1 to the power n minus 1, and 1 to the power alpha also 1. So then 100 over 2 to the power n minus 1, you can leave the answer like this. This is the sequence. T6 equal AR5, and nth term is T n ARn minus 1, and A value is 1, r is minus 2 over 1, that is minus 2. So this is a1 times r minus 2 to the power 5. So this is going to be minus 32. And Tn is a is 1 again. R is minus 2 to the power n minus 1. So 1 times anything multiplied by 1, the same answer, minus 2 to the power n minus 1. If you want, you can write like this, minus 1 times 2 to the power n minus 1. And then this is minus 1 to the power n minus 1 and 2 to the power n minus 1. But this is, you can stay from here. Question number 5. In terms of a geometric sequence, nth term is given as 2 times 5 to the power n. Now don't try to work out this is first term and this is ratio, because that assumption is wrong, because this may be a answer after simplification. For example, um, the real n term, it may be this one, Tn 10 times 5 to the power n. So 10 I can write 2 times 5 to the power 5 to the power n. I think that doesn't work. This should be n minus 1. Usually we know that uh, 1 less than n, so n minus 1. Then we write 10 times 5n over, I can write 5 minus 1. Then I can bring that 1 down, 5n over 5. So I bring this 5 to here. So then 5 to 5 cancel out. This is 2. 2 times 5n. Now you can see that this is the simplified version, not the simplified version of the nth term. Because of that, by looking at this, so straight away they have given the nth term. So don't decide this is first term and this is the ratio. When you look at this one, you can see that the first term is 10, not 2. So this is just an example. So when the nth term is given, don't try to apply the previous uh, basic knowledge, basic theories. Just work from here, because now nth term, find the fifth term. So then uh, first and the fifth term. So n equal 1, simply when you apply t1 is 2 times 5 to the power 1, that is 10. Then fifth terms t5, so 2 times 5 to the power 5, that is I have to get the calculator answer, 6250. Question number 6. 6 terms of a geometric sequence is 30. So 6 term is 32. 6 term also you can write first term times 1 less than with the common ratio. So then from here we can conclude AR5 equal 32. First equation. Then the third term is 4. Third term is 4. Third term we can write AR square. So then from here we can conclude AR square equal 4. So then R5 is R5 is the bigger power. So because of that, I will stay with 1 divided by 2. So AR5 divided by AR square equal 30 divided by 4. A to A cancel out. R5 minus 2 or 5 R's 1, 2, 3, 4, 5 divided by 2R 3R R cube equal 8. Then you want to get the third root, or 8 1/3. So this is become R. So this is 8. I can write 2 to the power 3 times 1 over third. 2 to the power 3 times 1 over third cancel out 2 to the power 1, which is 2. R equal 2. Find the first term and the common ratio. So now our common ratio we found, now R equal to first term, right? We'll go to the second equation. It's a small number. So from 2, A times R is 2 square equal 4. So A times 4 equal 4, A equal 1. Now question number 7. A geometric sequence has first term is 4, and third term is term 1. Third term is um, third term is 1. Find the two possible value of the 6 terms. So we want to find 6 terms. So we know that first term, we know that we don't know the second term, we know that third term is 1. So basically this is same as question number 3. Sorry, question number 6. So first term A equal 4 already. We have that. First term is 4. And third term T3 equal 1. Third also we can write AR square. So we can conclude AR square equal 1. This is 1 and this is 2. From 1 and 2, we know A equal 4. We'll substitute here. 4R square equal 1. So R square equal 1 over 4. R equal, we take the square root plus or minus half. Now we need a 6 term. That is 6 terms. AR 5. When R equal half, T6 equal A is 4 times half 5. So 4 over 32. That is 1 over 8. And R equal minus half, T6 equal 4 minus half 5. So this is, when you multiply, you can look at it, minus 4 over 32, which is minus 1 over 8. If I calculate this one bit more, 4 times minus 1 to the power 5, 2 to the power 5. So this is going to be 4 times, this is going to be a negative value, negative 1. So negative 1 times 2 to the power 5 is 32. So negative 4 over 32 minus 1 over 8.